okay? And eventually it's going to start to deteriorate that metal underneath there, all right? And eventually you're going to start to get some corrosion inside that metal, and eventually it's going to start to leak. Now, one thing about, having the insurance, like I said, besides doing the boiler inspections, we also insure all the boilers, okay? So if something happens to them and they blow up, or they take a walk like that other boiler we saw, that's covered from our insurance, okay? Now, the one thing that's not covered, and generally not covered by any insurance, is corrosion, okay? If you got a boiler that's failed because of corrosion, it just finally wasted away, the metal's wasted away because of poor water temperature control, a lot of times that won't be covered by the insurance, right? So another reason to keep the scale down to a minimum. Which brings us to our next thing, optimization. All right? A 1/4 inch of scale, 1/4 inch of scale, can actually cost you, increase your fuel cost, your fuel usage, by 70%, just from a 1/4 inch of scale. So one of the things our inspectors are going to start doing, as we come around to do our boiler inspections, we're going to start making what we call optimization recommendations. If we see a way that you can operate that equipment more efficiently, be it electrical, boilers, HVAC, or whatever, we're going to say, go ahead and clean off the scale. If you remove this much scale, you'll see your fuel cost is decreased by so much. Same thing about any type of air leaks or any type of soot buildup on the boilers. And we'll actually direct you to what we call our equipment efficiency calculators. We make a recommendation as far as to operate that boiler in the most optimum condition. We'll send you to this calculators. Like I said, we have calculators in 4 different sections: boilers, electrical, HVAC, and mechanical. And if you want to get some experience, just some idea of how much it would cost you, or how much you would save, you can go to one of our calculators and you put in the information on the type of boiler you have, as far as, fire tube, water tube, how it's being fired, on gas, on oil, whatever, design pressure, design temperature. If you fill that information in, you can actually start to see how much you might start to save just kind of knocking off the scale. In this particular instance, we had just 1/16 of an inch of scale, okay? And our estimated savings can be anywhere from $1,000 to $3,500 per year just on this one boiler, on fuel savings. And that's just 1/16 of an inch of scale being knocked off the boiler. And a lot of times, you see a lot more scale build up on that. So we'll start making some of these optimization recommendations. All right, another type of failure controls and safety devices. Okay, some of our control and safety devices would be safety relief valves, low water cutouts. What else? High temperature limit switches, pressure switches if you have any type of steam boiler or anything like that. Here's a safety valve. What's wrong with this safety valve? Yeah. Remember all that scale that we saw on the tubes? That scale can also start to build up on the inside of the safety valve. Do we have proper over safety protection on this boiler now? And that's the one thing. If our inspectors come in and we do an inspection and we have some reason to believe that that safety valve is no longer operable, we're going to have to recommend that you take that boiler offline, okay, and replace the safety valve before you can bring it back up again. Because that is a serious safety concern. What kind of things can you do to try to help prevent that, to help minimize that? Yeah, go ahead and pop that safety valve every so often. How many guys actually pop a safety valve in the facilities? Take the safety valve and lift it. Okay? We hear a lot of people say they don't like to lift them up, they don't like to test them because they never reseat. They never, they start to leak after you pop them once or twice. Well, the reason it does that is because you never tested it to begin with. All that scale and crud starts to build up on the seat of the valve and the disc. And so you don't have that good seating connection anymore. So of course it's going to leak, all right? Well, hell, if it leaked, it might not even work to begin with, right? How many guys have hot water heaters at home? You test those safety valves? Pop those when the last time you popped those puppies? You said this weekend? It's kind of hard. We recommend doing that. I recommend doing it like every 6 months, okay? I mean, that thing can go just as, I mean, we'll see a video on that, okay? What's wrong with the safety valve? Well, what happened, we came in to do we popped it, okay? And it was leaking. We did the test on it, and it was leaking, and they told the mechanic to go down there and keep it from leaking. Well, they stopped it from leaking, all right, okay? Anybody recognize what kind of vessel this is right here? Yeah, hot water tank, okay, hot water heater, okay? Now, unfortunately, we had this situation happen down in Oklahoma City back in '82. It wasn't just like this. I mean, this thing actually had a discharge line on it, and it was leaking. And the guy did the same thing. He went ahead and tried to keep it from leaking, and, you know, screwed a cap on it, okay? Unfortunately, you know, something happened to the temperature switch, and this thing just kept building up pressure, and the safety valve tried to relieve itself. Now, this was out of school, and this was in the cafeteria, and the whole tank finally let go right about lunchtime. And unfortunately, about 6 kids died from this. So, you know, that's why, you know, if we ever see any reason why a safety valve that we believe is not in operation or is not going to function properly, we will require you to take it offline and go ahead and shut it down. These things are dangerous. I recommend if you got a discharge line, which you should have a discharge line on these safety valves, you know, to point off to a safe point of discharge. At the bottom of the line, go ahead and, you know, cut it out at an angle. That'll prevent some enterprising young, you know, guy from putting a cap on it or something. Remember I told you about that low water cutout and how you're supposed to drain that ever so often? This is one reason why we like to drain those low water cutouts. A lot of times it's just an empty chamber with a floating ball in there. And this is what you can see that's, you know, can build up in here, a lot of sludge and a lot of mud. Is this low water cutout device don't work? Okay, that's why we recommend while the thing is running, while it's online, you go ahead and flush it out, okay? Flush it out until you get some clean water out of it. Flush it out and actually test the shutdown feature of it. This is the electrical side of the low water cutout device. And what do you think? How do you think this one looks?
A little crude.
We want to make sure we got the right type of wires for the high temperature application, okay? And you don't see this too much. A lot of them now are micro switches, but these are some of the old mercury switches, okay? If you have any of them that are like that with the old mercury switches, make sure the mercury's in good condition. Make sure it's a nice, solid, you know, blob of mercury in there. It's not cloudy. It's not speckled all throughout the bulb. Like I said, this is an older type, but there's still a lot of them out there like this. These are pressure temperature switches. Covers missing, you know. If you see anything like that, you definitely might want to go ahead and test that or replace it. You've got wires that are coming out of the connection box there. All right. I like this one. This is this pressure switch. Okay. Can you see anything wrong with this pressure switch? Huh?
Negative pressure?
Something's on
the mercury safety switch.
Yeah, piece of cardboard in there, okay? They were actually doing some type of maintenance and they were actually doing some type of test on this boiler. And they wanted to make sure it didn't trip off with overpressure or whatever. So to prevent that, they actually put in something to keep from tripping out, okay? anytime you bypass controls is never a good idea, because if they're left in there, you finally go to the inspection. That inspection might go a little difficult that day. All right, preventive boiler failures, okay? We'll make sure about the proper operation, proper maintenance, and routine inspections. If you operate these boilers in accordance with the standard procedures, if you are doing the type of maintenance that is required, and we do have routine inspections, we can help prevent a lot of boiler failures. And in this case, this is an example of it was being operated improperly. Obviously, the maintenance wasn't being done correctly, or it was done incorrectly. And obviously, the routine inspection, I want to have a disclaimer, we did not inspect this boiler, okay? It wasn't HSB. Obviously, the inspection didn't catch the things that were going wrong. Now, typically, if you have a boiler failure, it's usually going to take a series of events to happen. It's usually not going to be just one device go bad that's going to cause your boiler failure, okay? It's going to be a series of events. And that's what happened at this location. This is a 5.2 boiler. That's not the boiler room, okay? That's actually the manufacturing boiler. And the boiler room is right adjacent to it. The boiler's not supposed to be in there. And this is what the boiler looks like. So what do you think happened on this boiler? Low water. Got that classic melting of the main furnace, okay? Unfortunately, you just didn't get a, failure of the boiler. You just didn't get extensive damage. You got catastrophic failure. When that sheet actually let loose, and all the water, whatever water was left in there, expanded to steam, this thing took off like a rocket, and it went into the adjacent room. Took down a lot of pieces of equipment, and it's America no one was killed in this thing. Okay, there's a boiler back there. This is the boiler room. This is where it's supposed to be, okay? In fact, this is the exhaust jack. So this is where the boiler started, and that's where it ended up at. You see, that's a pretty decent sized ball to knock the hole through, okay? That's the outside wall of the boiler room. And this is looking at the outside of the boiler room from the east side. Yeah, from the outside side. So you can see it actually took the outside wall down also. Basically what happened when the boiler let go, that back door, the back furnace door, went one way and took out that wall, and the boiler went the opposite way and took out the opposite wall. There's a sister boiler right there. And take a look at that back door on this one. This is not the one that failed, okay? But there's the back door of the one that failed. There's the boiler room, and there's the back door there. So you can see this thing kind of took off and landed several hundred feet away. Like I said, it's a miracle no one died in this thing. See how thick these walls are right here. Earlier we talked about proper operation, proper maintenance, proper inspections. Well, here they weren't operating the boiler properly. Because these things, these boilers operate automatically, okay? As the water level goes down, it's supposed to automatically call for more water. Typically on these size boilers, you're going to have about 2 low water cutoff lights. One to turn the pumps on to bring the water into the boiler, and the second as a backup to actually turn the fire off when water gets too low. Now, for some reason, they were having problems with the automatic feed level coming to the boiler. And this is the